my two series are such that the terms in the A series are less than or equal to the individual terms in the B series. And you know that the B sub n converges, then you're guaranteed that A sub n will converge. If the A sub n diverges, then you're guaranteed that B sub n will diverge. And I hope I'm going to help you see why this makes good sense.
So the smaller one diverges and the big one diverges. The big one converges and the small one converges.
And that's exactly what the theorem says. Excellent. Took me a long time to get that. Good for you. So just exactly what he said. If the big one converges, and you know it's bigger than something else, then that little one has to converge also. If, on the other hand, this little one blows up, and this is bigger than that, it's got to blow up too. Nice test, but you have to come up with your own series to compare to. So they'll give you one and say, does this converge or diverge? And then you've got to hunt around for something to compare it to. If you're hoping that it's going to converge, you find something bigger than it that converges. If you hope for it to diverge, you find something smaller than it that diverges. So let me give you an example. I need a shortcut for this. What can I write from now on? Because I'm getting tired of writing determine convergence or divergence.
Just put con and
Put
C
C or D.
C or D.
Hot dog. C-O-D. Perfect.
Chord.
Or COD.
Cash on delivery, that's even better.
Call it. Obsession.
So suppose I asked you whether this series, 1 over 2 plus 3 to the n, does that series converge or diverge?
You do 1 over 3 to the n. And the B series.
So what we're going to do is, in our heads, think about comparing. That's a great one. And the reason that's a great one is because we know this one. That's really, okay, now don't say anything. Able.
Yes.
Rewrite that so I can recognize it.
That's 1/3. The whole thing raised to the end.
That's 1/3 to the n power, which is a,
Geometric.
and it converges. This thing is a convergent geometric. So because the R value is 1/3. Oh, you're okay? Okay, so now, since that one converges, what I'm hoping is that this will be less than or equal to this. If this big one converges, anything that it's bigger than is going to have to converge. But can I make that argument?
2 plus 3 to the n is greater than 3 to the n. So since it's over 1, it's going to be smaller.
The bigger the denominator, when the numerators are the same, the smaller the fraction. So we're in good shape, and we can make this argument. So here's what you would argue. You'd argue that 2 plus 3 to the n is greater than or equal to 3 to the n, and therefore, this is a true statement. So we've got that this is true. Since this one converges by direct comparison test,
Well, since they're in the denominator, that would have to be smaller.
the bigger the denominator,
Yeah, so it
the
has to be-
smaller the
yeah.
fraction. Yes, because both of them had the same numerators.
Okay.
I was like 5 divided direct comparison test. This sum, 1 over 2 plus 3 to the n converges. But the trick is, can you find one of your other series that you know whether it converges or diverges? And this one wasn't too bad. You picked it up really fast, 1 over 3 to the n over a. You know, that gave you a nice geometric. So
Do it.
we're done with that one.